is that it's highly toxic. I mentioned that just a short time ago, right? We don't use it as a cleaner for nothing. It makes a good cleaner because it kills stuff. It is an extremely toxic molecule, and it's capable of moving through an organism pretty freely, right? It can move across membranes, right? So what we need to do, if we're going to use ammonia and leave it as ammonia, we need to have a mechanism for getting rid of it. So this first group of animals, most of the aquatic animals, their major form of nitrogenous waste is ammonia, and then they also have ammonium ions, right, because this right, you've got ammonia, you've got ammonia. You need water to get rid of ammonia. So what you're going to do is just kind of like flush this excretory system with lots of water. That pulls the ammonia out with it, and then you can get rid of it through excretion. So if I'm a fish here, I'm pushing the ammonia out with lots of water. As soon as the ammonia hits this aquatic environment, it's going to diffuse quickly away from the fish because it's concentrated close to the fish where it went to the bathroom, and it begins to immediately diffuse away. So if I live in water, I have a mechanism for getting rid of the ammonia. I simply use diffusion, and diffusion can take care of the problem. Now, if you live on land, this is not an option because you need lots of water to get rid of ammonia. Well, you don't have a lot of water to begin with, most likely, unless you live in a pond or something. So some organisms, like mammals, most amphibians, some of the reptiles, and a tiny group of marine fish, what they do is convert ammonia into a molecule that's less toxic. So here, the ammonia can be converted from its high toxic state into a low toxicity state, which is urea. What this means is organisms don't have to get rid of this ammonia all the time like a fish does. You produce the ammonia, you got to get rid of it, get rid of it, get rid of it all the time. But it's okay, you live in the lake, you can just excrete it out all the time. On the other hand, if I'm a squirrel, I'd like to be able to go to the bathroom only a few times a day, right? So what I could do is store stuff away in that urinary bladder, but I can't store ammonia because it's highly toxic and it can move across membranes. So instead what I'm going to do is generate this urea. It's less toxic, I can store it in a urinary bladder, and then I can make decisions about when I want to do the excretion process. Okay? That's the advantage of urea. The disadvantage is it does cost energy to convert it. So mammals spend energy to convert ammonia to urea. That's the downside, the loss of ATP, but the upside is it's less toxic. Now, there are other groups of animals that manufacture a molecule called uric acid. This would be the reptiles, birds, and insects. Uric acid differs from ammonia and urea in that we're not talking about a liquid here. Uric acid is insoluble in water. And as a consequence, uric acid is more of a paste. It has the benefit of being very low toxicity, just like urea. The downside is it costs more energy to convert it to uric acid than it does to convert it to urea. So there must be some kind of a benefit to making uric acid rather than urea, since this would be less expensive. And the benefit is, if you're going to make it urea, you need to use water to get rid of it, whereas uric acid, it's a paste. It's not you don't need water to get rid of it. In fact, if I live in a region that's arid, like I'm thinking a reptile here, or an insect, or a bird that doesn't have access to a lot of water, I can get rid of my nitrogenous waste without having to use water to get rid of it. So it's a natural advantage